So we're trying to find the domain of those rational functions. So rational functions is a little bit difficult to really understand in the beginning, but the more we practice, the better we understand it. So let's try this. So let's try one. So when we talk about domain of a rational function, so what do? We take the domain. So basically, so how do we find the domain of rational function? Because rational function is a special kind of function. The domain is super important. So what do? We basically take the denominator and we set not equal to 0. Okay, denominator not equal to 0. And then we write equal to 0. Then I have a slash through this equal sign to say, okay, not equal to 0. So the denominator in this case, in the first one, is 2x minus 5. So we just do that. Let's say, okay, 2x minus 5 not equal to 0. Again, write down equal to 0, then I slash through the equal sign. So solve this, of course, you get x not equal to 5/2. So that means this function works for all real numbers but 5/2. Okay, only 5/2 is not working for this function, because if we plug in 5/2 with x, 2 times 5/2 is 5. 5 minus 5, that's 0. But anything divided by 0 does not exist in mathematics. Right? Think about it in life. If I have 5 apples shared by nobody, it just doesn't make sense, right? We don't consider the situation. So that's why in mathematics, we don't deal with the denominator to be 0. Or to say whenever the denominator is 0, it's illegal in mathematics because it does not exist. Okay, let's see the second one. Second one, the denominator is x squared plus 9. Will this ever be 0 in real number world? Well, in real number world, x squared is at least 0, right? Which means x squared is greater than or equal to 0. Then at the 9 on both sides, that means the denominator is at least 9. So will never be 0. So what is its domain? Its domain is all real numbers. How do we indicate that? We see that's from -infinity up to positive infinity. Or we see just all real numbers. Okay, so this rational function, even it's a rational function, but it works with all real numbers. Now let's see this one. So this is x cubed. So we write down first. We follow this. Denominator not equal to 0. So that means x cubed minus 1 cannot be 0. Not equal to 0. Then we solve this. We solve this not equal equation. All right. So how do we solve this? We add 1 on both sides. So we get x cubed equals to 1. Then we cubic both sides, right? We cubic both sides. Then the left-hand side, we get x. What's the cubic of x? 1. It's just 1. So x not equal to 1. I have to change this to be not equal to, okay. So x can be any number, just not 1. All right, how do we write domain? We can write in interval notation to see, okay, the domain goes from -infinity up to 1, not including 1, so use close parentheses, union 1, open parentheses, not including 1, up to positive infinity. So this notation successfully omit the value 1. So it's the same as x not equal to 1. Let's say 4. X squared minus 4. Difference of two squares. Right? Difference of two squares. So we can write as x minus 2 times x plus 2. Because 4 is 2 squared. So we can write as this. And then we see, okay, this cannot be 0. So let me slash through the equal sign. This is not equal to 0. We have two factors. That means x minus 2 cannot be 0, and x plus 2 cannot be 0. So that means x cannot be 2 and -2. Okay, similarly, so this is saying x, any x value works for this function, but 2 and -2. So omit those two numbers. So this also difference of two squares can be written as x plus 4 times x minus 4. Right, that cannot be 0. When we solve, we see that means x cannot be 4 and -4. We can write as x not equal to 4 and -4, or we can write in the interval notation to see x can go from -infinity up to -4, then union -4 to 4, then union 4 to infinity. So similarly, this is x cannot be 3 and -3. Right. Well, now let's look at this one. This one can be factored. So this one can be factored as x minus 6 and x plus 1. So this cannot be 0. Denominator cannot be 0. Whatever the denominator is, we see we cannot be 0. So we solve this, we get x equals 6 and the -1 x, that means x cannot be 6, cannot be -1. So all real numbers work with this function, but 6, but -1. Difference of two cubes, because a is 2 raised by 3. So this one we can factor to be x minus 2 times x squared plus 2x plus 4. So that cannot be 0. So this is by difference of two cubes formula. So we have two factors. One factor is x minus 2. One factor is x squared plus 2x plus 4. Okay. So those two cannot be 0. So we get a 1 is x cannot be 2. So x cannot be 2. And this one, we see we don't really have real, because we can use quadratic formula. -b plus minus square root of b squared minus 4ac divided by 2a. Then we see the discriminant is b is 2. 2 squared is 4. 4 minus 4 b squared minus 4ac. That's 4 times 4, 16. So 4 minus 16 is the square root of negative 12. That's not a real number, right? So this one will never be 0. So only x minus 2 can be 0. So that means x cannot be 2, right? So the domain of this function is x cannot be 2. So we can write it as negative infinity goes to 2, goes up to 2. Then union 2 goes up to positive infinity. All right, so 2 notations. So this one is called an interval notation. You know, I don't know if your teacher asked her which one. And this one is called a set notation. Now let's see this one. So now you can see it's, you know, it's a factoring, right? It requires factoring. So we have x squared plus 6x minus 9. Think about 2 factors of negative 9. If it's factorable, right? Negative 9, then the 2 factors of negative 9 adds up to be 6. Or in this case, we can do that. So what do? We use the formula of quadratic formula. Quadratic formula. Which is, which is negative b. It's a little bit difficult for me to write this way. Negative b, what is b? B is the number before x plus minus square root of b squared. B is 6 minus 4ac. 4ac all divided by 2a. So this is to find the factors of x. All right. So what's a? A is the number before x squared, which is 1 in this case. What's a c? C is the number of the constant term, which is negative 9. So just plug in those numbers, right? Try to see this number. Then this number, once you figure out, is a factor of x. You see you have 2. One is a plus, one is a minus here.